Question 2, name the mechanism of reaction of concentrated sulfuric acid with alkene, electrophilic addition. And then this, question 2.2, double bond to the H positive, then to the HO to the oxygen delta negative, then you get that oxygen lone pair electron negative charge to carbon cation. But I want the formation of major product, so it's got to be to this carbon. If it was here, that would be primary alcohol. In this case, it's going to be a secondary. It's going to be secondary carbon cation, and then you get that. Your structure minor product, well, it's just going to be here. Explain what the product is a major product. Well, the idea that major product is formed by more stable carbon cation, positive inductive effect of two alkyl groups compared to one due to electron dash releasing character. Draw skeletal formula 3 isomeric alkenes for the reaction of butane to concentrated sulfuric acid. So you got that skeletal formula, but1ene, then you've got E-but2ene, the enemies, and then you got Z-but2ene on the same side. Name this byproduct, identify the role of sulfuric acid formation, and name a method to separate the products of the reaction. C4H8O, that's butanone. The role of sulfuric acid, oxidizing agent, because I'm reacting butane 2O concentrated sulfuric acid as oxidizing agent. Name a separation method, fractional distillation. Give the observation when concentrated sulfuric acid reacts with solid sodium chloride, steamy fume / white. Role of sulfuric acid is a proton donor. Identify product responsible for each observation. The black solid is going to be the iodine, the yellow solid is the sulfur, and the gas H2S that smells of bad eggs, hydrogen sulfide. Stress had anti-pumping granules prevent bumping during reflux to prevent the formation of large bubbles. Show by calculation excess sodium hydroxide used in this reaction. Density is mass of volume, mass is density time by volume. Find the moles of ethyl benzoate and find the moles of sodium hydroxide. And you can show that it's excess sodium hydroxide used in this reaction because 1-to-1 mole ratio, but that's not 1-to-1, that's an excess. Suggest when excess sodium hydroxide is used to ensure all the ester reacts. That's when excess is used. Suggest when electric heater is used where the Bunsen burner flame in this hydrolysis, ethanol is flammable. State why reflux is used in hydrolysis. Reflux allows reactant vapors to be returned to the reaction mixture, aka does not allow any reactant vapors to escape. Write an equation for reaction between sodium benzoate and hydrochloric acid, C6H5CO Na plus HCl to form C6H5COH plus NaCl. Suggest why sodium benzoate is soluble in cold water, benzoic acid is insoluble in cold water. Sodium benzoate is soluble because ionic. Benzoic acid is insoluble despite polarity of COOH group. Benzene ring is nonpolar. Therefore insoluble in cold water. Describe method students should use to purify benzoic acid. Organic solids can be purified by recrystallization. So dissolve crude product in a hot solvent of minimal volume, filter hot to remove insoluble impurities, cool to recrystallize, filter under reduced pressure with Buchner funnel, wash with cold solvent and dry to remove soluble impurities from the surface, and then leave the purified crystals to dry. Or in this case, leave the purified benzoic acid to dry. Calculate percentage of benzoic acid. So moles of benzoic acid and the moles of ethyl benzoate, which I've already got. So actual yield is theoretical yield, and times by 100, get 105%. For percentage yield, don't need to always calculate in mass. You can use moles as well to substitute the moles in. So just why the yield is not 100% because the product is not dry, therefore impurities are present in the product. So just the pH range is a suitable indicator for this reaction. For this titration, go to the here, and then halfway between here, so 7 to 10.2. Give the expression for acid dissociation constant Hx. K is concentration H plus X minus divided by concentration Hx. Calculate concentration Hx in original solution. Well, moles of sodium hydroxide 24 times by 10 to the power minus 3 times by 0.100. You get that, and then concentration Hx is going to be 2.4 times by 10 to the power minus 3 divided by the volume 25 times by 10 to the power minus 3. You get concentration as that. Calculate pH of solution of Hx before the addition of any sodium hydroxide. So you fill it in and you get that. And the K is concentration H plus squared divided by concentration Hx. Concentration H plus is square root of Ka, which they have given you in question 2.62 times by 10 to the power minus 5 times by the concentration Hx 0.0960 to find out. Then use pH minus log 10 concentration H plus to find out pH. Calculate pH of solution with half of the acid as reactant. Now this one's a bit of a tricky one because you need to identify half of the acid as reacted, therefore it's going to be half neutralization, therefore pH equals pKa of weak acid, therefore pKa is minus log 10 Ka, because I'm not given pKa, I'm given Ka, and Ka is 10 to the power minus pK, but pK is minus log 10 Ka. Once I've got pKa, then I know pH equals pK of weak acid, therefore pH is the pKa, which is 4.58. And plot your answers question 4.4 and 4.5, just plot it, and then sketch the missing part like that.